Prime factorization. Prime factorization occurs when we divide the numbers into all prime numbers. One method for finding these numbers is to use a factor tree, which we'll use in the first example. So what is the prime factorization of 480? So to answer this, we would take the number like this, and we see that it ends in a 0. So we know we can divide it by 2. So 2 can go into 480 how many times? So 2 can go into 4, 2 times, 2 can go to 8, 4 times, 2 can go to 0, 0. And we're left with no remainders in each of those. So it's 240. Now we can go 240 divided by 2. We'll just divide it again by the prime number 2. So 2 can go to 2 one time, 2 can go to 4 2 times, 2 can go to 0 0 times. So now we're left with 120. So now we have 2 going into 120 now. 2 can't go into 1, so it can go into 12 6 times. 2 can go to 0 0 times. So we just cut everything in half is all we're doing. So 480 divided by half is 240, and so on. So now we have 60. Let's go on and continue to go with 2. 2 can go into 60 how many times? 2 can go to 6 3 times. 2 can go to 0 0 times. Next we have 30. Let's divide that by 2. 2 can go to 3 one time. We're left with a 1 remainder. 2 can go into 10 5 times. And then now we're left with 15. We can no longer divide by 2. So this can be divided by 3, which 3 into 15 gets 5. So our prime numbers for this is 2, 3, and 5. So how we would do this is we take 2. How many copies do we have? We have 1, 2, 3, 4, 5. So we would raise to the 5th power, which is the exponent. This is our base number, this is our exponent, to say that we have 5 copies of 2 times 3 times 5. So that is how we would show the prime factorization of 480. Now let's do another example. But with this example, let's use a second method by using the divisibility ladder. Now let's look at example 2. What is the prime factorization of 1,890? So now we have 1,890, and instead of doing a factor tree, we're doing a divisibility ladder. So what we do is we put the prime numbers on the left of our number that we're dividing by. So we can say 1,890 can be divided by 2 because it ends with an even number, which is 0. So 2 can go into 1,890 how many times? So 2 can go into 18 9 times. Then we go 2 goes into 9 4 times. 2 times 4 is 8, so then we're left with 9 minus 8, so we have a 1 left over. So now we have 10. 2 can go to 10 5 times. So now we're left with 945. So we do the same thing. We close it in, and this time we're going to divide by 5. Now 5 can go into 945 how many times? So 5 can go into 9 one time. We have a remainder of 4, so now we have 44. 5 can go to 44 8 times. 5 times 8 is 40. So 44 minus 40 is 4. So we have a remainder again of 4. So that now we have 45. So 5 can go into 45 9 times, because 5 times 9 is 45. And we're left with no remainder, which is what we want. So now we have 189. And we know 1 plus 8 is 9, plus 9 is 18. And 18 can be divided by 3, so we know this is divisible by 3. So we're going to go ahead and divide by the prime number 3. So now 3 can go into 18 6 times, because 3 times 6 is 18. Now we have no remainder, so we're left with just this 9. 3 can go into 9 3 times. So now we have 63. 63 can be divided by 3. 3 goes into 6 2 times. 3 can go into 3 1 time. Now 21. This can be divided by 3, and 21 divided by 3 is equal to 7. So, and this 7 is a prime number. So now we know we're done because we only have prime numbers on the outside. So we have 1, 2, and how many copies of 3 do we have? We have 1, 2, 3. So we go 3 raised to the third power to show the number of copies, which is our exponent number, times 5 times 7. And this would be our solution. Now let's do one final example. What is the prime factorization of 240? So we have 240. Let's use our divisibility ladder on this one. So we can divide by 2. 2 can go into 240 how many times? So 2 goes into 2 1 time with no remainder. Now 2 can go to 4 2 times. 2 can go to 0 0 times. Now we're left with 120. Let's divide this by 2 again. 2 goes into 120. So 2 can go to 12 6 times. 2 goes into 0 0 times. Now 60 divided by 2. 2 goes into 6 3 times. 2 goes into 0 0 times. Now let's do it again. 2 goes into 30. 30 can be divided by 2. 2 goes into 3 1 time. We left with the 1. 2 goes into 10 5 times. So now we have 15, which can be divided by 3 and 5. And so these are the prime factorization of 240. So once again, we have our prime numbers. So we have 4 copies of 2 times 3 times 5. And this would be the prime factorization of 240.